Physics Blender. I love 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 Physics Blender. Subscribe for more videos.
Hello everyone, welcome to Physics Blender e-learning platform. Today we are discussing pressure. We have paper 1 for core and extended candidates. Before we start, please you have to read what you have in your CIE specifications, and as usual we start by our KWL chart. Write down what you know about pressure, what you want to know about pressure. At the end, check that you have learned what is written here in your specifications. Okay, let's start by question number 1. Question number 1, we have here table gives you 4 forces and the surface area acting on which each force acts. Okay, so we have which row gives the largest pressure on the surface. We have 4 cases. You have to apply the equation used to calculate pressure. Pressure is equal to force, the applied force in Newton, divided by the contact area or base area measured in squared meters. Okay, so in case A, you have to calculate pressure, which is 20 divided by 2. The answer is 10 Newton per squared meters. And in case B, pressure will be equal to 40 divided by 2, which is 20 newtons per squared meters. In row C, pressure will be equal to 20 divided by 4. The answer is 5 newtons per squared meters. In row D, pressure will be equal to 40 divided by 4 is also 10 newtons per squared meters. So it's clear that the largest pressure is B. So the correct answer is B. Question number 2. We have a T-shaped girder is placed on the ground in position X, then turned over to position Y. So we are talking here about the same object. Same object means same weight, same force applied on base area. Back to our equation, pressure is equal to force divided by area. The factor which is constant here is the applied force. The applied force here is constant, which is the weight of the girder. So the relation between pressure and area, they are inversely proportional. In position X, you have the base area is large, but in position Y, you have here the base area is small. The question is asking you what happens to the force on the ground and what happens to the pressure on the ground. The force here is constant. Why? The force here is representing the weight of the girder. The weight is constant. We are talking about the same object. So you have to exclude A and B. You have to choose between C and D. So in position, what happens to the pressure on the ground? When it turned over, as I told you, you have here the base area is decreased, base area decreased, so pressure increased. So the correct answer is C. Base area decreased, pressure increased at constant force. And force here, the applied force here is the weight of the object. Is it clear? Question 3, we have here diagram showing different shapes. Okay, we have a vase, each has same base area, each one contains water and same depth of water. Which statement about the water pressures at points P, Q, and R is correct? Here we have to clarify very important concept about pressure of liquid. Here we are not talking about solid object on surface, we are discussing pressure of liquid. Okay, for extended candidates, you know the equation used, pressure depends on density, rho GH, density, and the depth of liquid. Okay, for core candidates, you have to know the concept that pressure of liquid depends only on the vertical depth, and it doesn't depend on the shape of the tube, the width of the tube. If you look at 3 different containers here and you look at the height of water, you will find that water height is the same in each case, although you have different shapes for the container. Okay, so the correct answer for this question about the water pressures at points P, Q, and R is D. You have pressures at points P, Q, and R will be the same. Why? Because here it depends on depth of liquid, it depends on density of liquid. Question 4, we have here diagrams showing the actual sizes of heels of 4 different shoes. Okay, which heel is most likely to cause damage to wooden floors? Back to our equation, we have pressure is equal to applied force divided by base area. We will assume here the force will be constant, which is the average weight of normal person. Okay, so if we consider here, if we assume the force is constant, which is the weight of the person or the average weight of the person, we assume, okay, to make fair comparison, so area and pressure will be inversely proportional. So most likely to cause damage, the one which has greatest pressure, which means least base area. So if the area decreased, the pressure will be increased. Which one here has least base area? A. Question 5, we have here a vehicle sinks into soft ground. Which change is made now? The vehicle is changed so it doesn't sink as far. According to the equation we are using, pressure is equal to force divided by area. The factor which is kept constant here is the weight of the vehicle. So the weight here is constant. The weight here is constant, which is the weight of the vehicle. It doesn't sink anymore. It means the pressure becomes less than before. So decreasing pressure means increasing base area. Increasing base area means wider tires. We are using wider tires. The correct answer is D, which means the weight of the vehicle is spread over greater area, causing less pressure. Question 6. Back to pressure of liquid. Pressure due to liquid column. Diagram 1 showing conical flask containing water. Diagram 2 showing beaker. They have the same base area as the flask. Both have the same base area containing water at same depth. Again, guys, the pressure of liquid depends only on the vertical depth of liquid. It doesn't depend on the shape of the container or the width of the tube or the container. Okay? So the correct answer here is A. The pressure at P is equal to pressure at X. Since we have same liquid, we have same depth. Changing the shape of the container, it's not a factor if you are comparing pressure of liquid. Is it clear? Question 7, here we have an athlete exerting least pressure on the ground, which diagram showing the position when the athlete exerting least pressure on the ground. Okay, back to our equation. Pressure is equal to force divided by area. The force, the applied force here is the weight of the athlete, which is constant. Okay, so when you compare, here you are looking for least pressure. So pressure decreased means base area increased. So which case here, the contact area is greatest in position B. Okay, so the pressure will be least pressure. Question 8, we have 4 identical beakers filled with equal volumes of liquids, P or Q. But we have here liquid P denser than liquid Q. At which point is the pressure the least? Okay, here we have 2 factors affecting the pressure of liquid. Density of liquid, depth of liquid. Okay? For extended candidates, you know that pressure difference can be calculated using equation rho GH. Okay? For extended candidates. Okay. So here, at which point the pressure is least? Least pressure, so you have to compare density. So less dense liquid, its pressure will be less. And if we have shallow depth, also the pressure will be least. So which liquid here is less dense? So we are looking for least pressure. Least pressure, so you have to look for less dense liquid. Which liquid here is less dense? Liquid Q. Liquid Q. So you have to compare to exclude liquid P because it's denser. So we have to exclude A and B. So liquid Q is less dense, which means least pressure. What about which point? Which point here it has least pressure? Which point here the pressure will be least? The shallower one, the one which is located at smaller or shallow depth, which is D. So here D is shallower than C. Okay, D is shallower than C. So your correct answer is D. Again, why? Because we are looking for case of least pressure. Okay, so we have two factors. In case D, you have here shallow depth and the liquid less dense liquid. Question 9, we have two identical fish tanks are filled to the same level with water. One tank contains fresh water, the other one contains sea water. And you know seawater is denser than fresh water. Which fish experiences greatest pressure? Again, for extended candidates, the factors affecting pressure due to liquid depends on density, rho G, and depth H. So the two factors affecting pressure due to liquid, density of liquid, depth of liquid. Here we are looking for greatest pressure, case of greatest pressure. So we have to look at seawater tank. Okay? Because seawater is denser than fresh water, which fish, B or D, experiences greatest pressure? The one which is located at deeper location. So D is the correct answer because it's deeper than fish B. Okay? So this is the correct answer. Question 10, we have a student places 4 identical beakers on a bench. 2 beakers contain salt water and we have the other 2 beakers containing pure water. The density is given, which beaker exerts greatest pressure. So here we are looking for case of greatest pressure. Density of seawater is greater than, or salt water is greater than density of pure water. So you have to exclude now pure water because you are looking for greatest pressure. You have to compare between or choose between A and B. A and B. The other factor affecting pressure of liquid is depth of liquid. Which beaker, A or B, you have here more depth of salt water? It's clear that depth here of water is greater than in case B. So your correct answer is A because it has greater density, the liquid inside the container, greater density, salt water, and it's deeper than case B. Question 11, which situation is an example of force acting over large area to produce small force? Large area, large contact area or base area to produce small force. A builder hammering a nail, a cook using a sharp knife, nail, sharp knife, needle. All these cases, they are not large area. They are representing examples for small area. So the correct answer here is a soldier marching in flat-soled boots. Here you have boots, they have large area, so small pressure will be produced. According to our equation, pressure is equal to force divided by area. Force here is constant, which is the weight of the mixer. So we are trying to decrease pressure by increasing the contact area or base area. Again, why we are doing this? The weight will be spread over greater area, and this will help or allow the pressure to be decreased. The correct answer will be A. Question 13, we have a heavy table has 6 legs. The area of cross section of each leg is X, and the legs of the table make marks in a carpet. How can we overcome, or how can we reduce the depth of the marks for a table of a fixed weight? Fixed weight means constant force. So we are not changing part of the table. We have same table, same weight, but we are trying to change the other factors. Back to our equation, pressure is equal to force divided by area. Here the weight of the table is constant. The force here representing the weight of the table. So we are trying to decrease or reduce the depth of the marks, means reducing pressure. Reducing pressure. By decreasing or reducing pressure, we have to increase contact area, base area. Okay, so we have here options: using 3 legs, using 4 legs. We have already 6 legs, so we can use more legs. Why? Again, to distribute or to spread over, the same weight will be spread over greater area. The same weight will be spread over greater area. So we can use 8 legs, each of an area same as X, but in this case the pressure will be decreased. Question 14, we have 4 blocks, each weighing 10 Newton, rest on a horizontal table. Which block applies greatest pressure on the table? Okay, since they are identical, they have the same weight, back to our equation, pressure is equal to force divided by area. So here the applied force is the weight of blocks. Which block applies greatest area? According to the factors we have here, the force acting here over a small area gives larger pressure. So greatest pressure means small contact or base area. Which case here representing this case? Smaller base area is A. Okay, so the smaller base area here, which is shown in the diagram, is A. The last question we have today, question 15. 2 boys X and Y have the same total weight. So back to our equation again, pressure is equal to force divided by area. The force here, the weight of the boys, they have same weight, which is constant. Which boy more likely to sink into soft ground, and why? More likely to sink means greater or larger pressure, which means less or smaller base area. So more likely to sink means greater pressure, less area. Which boy here has less base area? It's clear that boy X, okay, boy X. So the contact area here is less and the pressure on the ground will be more. So the correct answer is A. Be ready for the homework and the quiz. And if you would like to find all documents, mark schemes, you can join Physics Blender Telegram channel.
Subscribe for more videos. I love Physics Blender. I love Physics Blender. I love Physics Blender. I love Physics Blender.